The core of what data scientists do is solving business case problems, so it's not surprising that a lot of companies such as Amazon, Google, and Meta will ask business case studies. So in this video, just like the video I published last week, we're gonna go through another case problem together. I'll give you the demonstration along with the commentary that can be helpful in cultivating your ability to solve business case problems impromptu. Let's get started. Most of us have used Amazon.com before, whether we're shopping for books or we're shopping on Amazon Fresh. Amazon.com is no doubt the go-to website when it comes to shopping experience online. So today's business case problem is based on this. How would you predict customer lifetime value or CLV of Amazon shoppers? Provide a recommendation on how to increase the CLV to the VP of product. Now, if you're watching this, most likely you're preparing for data science interview, and I want this to be really helpful. So instead of just passively watching it, I would recommend you actually try this problem and then leave it in the comment section below. For the first 5 comments, I'll actually provide my own personal feedback on your response. Now let's dive into the problem. When it comes to solving any business case problems, the first thing you want to do is start with some clarification. Imagine you go to a doctor and the doctor doesn't even do some basic diagnosis. They just immediately prescribe you with some drug or some surgery. So similarly, what interviewers are looking for is that if you're given some open-ended business case problem, can you ask clarifying questions and make the right assumptions to really define the parameters of the problem? So let me give you a demonstration of how I'm going about doing this. Alright, so I know that this is a 2-step problem. The first thing I need to have is a model that's going to predict the customer lifetime value of Amazon shoppers. And then I would most likely need to use this model to provide a recommendation that can help increase the customer lifetime value and think about how I'm going to package this information to the VP of product. So the first thing I want to do, even before I come up with what could be the technical solution, is to clarify the problem. And if I'm going to clarify the problem, I want to understand the business process. I want to talk about the business requirements. And I want to talk about the data sources that I can use to build this model. And in order for me to talk about the business process, basically I want to just briefly walk through the user journey. So I know that the way Amazon.com works is that a user is going to visit Amazon.com and then they might browse some couple items that they're interested in, and then it's going to be shipped to them in the shipping address that they have provided. And there's also a sign-up process for stuff like Prime membership, and that will waive shipping costs. And there's also various other ways Amazon can engage customers through emails and push notifications. Now, let me also talk about the business requirement. So I think that in order to solve this problem, and we can kind of talk a little bit more about this, is that we have to think about what is going to be the prediction horizon. And here's what I mean by that. So when we're trying to predict the customer lifetime value, it doesn't literally mean that we're going to predict what their purchase amount is going to be over the course of the next 100 years of a customer. So we need to have some sort of like a cutoff saying, okay, we're going to use some number of transaction history and predict their next 1 month sales or predict the next 12 months and so forth. And I would say that for the sake of simplicity in this case, I think 1 year should be sufficient. The next thing to talk about is a prediction point. So at what stage of a customer lifecycle do we want to predict their customer lifetime value? Is it going to be the first day that they've signed up? Or is it going to be the first week, the first month? Or is it going to be a moving target where on a month-to-month basis, we have a snapshot about what their transaction history has been, and then we're predicting what the next 1 year customer lifetime value is going to be. So it's basically sort of like a real-time update on a monthly basis. Now, depending on what we are trying to pick out, there's a trade-off around it. So for instance, if we're trying to predict based on, let's just say 1 day, 1 week, we're going to be able to quickly assess what the customer lifetime value is going to be for a customer. However, the problem with this is that the prediction accuracy might not be as accurate because we're trying to predict what their long-term purchase pattern is going to be based on a short window of time. But if we were to do it maybe, okay, we're going to get 3 months of their transaction history and then predict their next 1 year purchase, then in that case, we might have to wait quite a bit. And so that might be a little bit problematic for the business. And so I think the sweet spot is going to be 1 month. And in terms of the frequency, do we want this to be a moving target where on a month-to-month basis, we're predicting what the next 1 year is going to be? Or do we want to predict, all right, just based on their first month, let's predict the next 12 months? I would say just for the sake of simplicity in this case, let's predict based on the first month. And of course, I just want to mention that this model is basically the minimum viable product, and we can calibrate this model based on additional requirements that might come about later down the road. The next thing I want to talk about is the prediction frequency. So do we want this prediction to happen on a real-time basis, or do we want to happen on a batch basis? And that usually depends on the use case. Now, considering that users have joined and they have established that first month checkpoint at any given point in time, I think it makes sense to build a real-time system in this case. But of course, there are some other instances where you want to do some sort of like a batch process. So for instance, if you're maybe trying to predict sales at the total level, then you might have some sort of like a update frequency where it might be done on a weekly basis or a monthly basis. Now let me talk about data sources. So I believe that there are 4 predominant data sources for this type of problem. So there's the user, there's the device, there's stuff about marketing, and then lastly, there's stuff about transaction. So the user information are stuff that's provided when a user sets up the account. It's their name, it's their email, and it's going to be their address. And the device information are stuff about what type of device they use to basically make the purchase. So it's stuff like Windows, Mac, iPhone, Android. And there's also other information that's useful as well. So IP address as well. And there's also stuff about marketing that's important. So how did a user land on Amazon.com? Was it through SEO? So for instance, let's just say that users on Google search and they search diapers. And the very first thing that they see on the very top is the ads by Amazon. And they click it, and that will be an example of how the user has landed Amazon.com through the SEO. And another example might be also email notification as well, or push notification. So these are essentially what are some external tools that Amazon using in order to get users to get onto Amazon.com and start shopping. And I would say really the most important data source in this case is going to be the transaction. The transaction data source is going to provide a lot of information that we need in order to build out the features, but it's also how we're going to get the labels. So the transaction information should have information about the payment method. What kind of, did they use a credit card? Did they use gift card? Did they use debit card? And there's also information about the product that they purchased, along with the price and quantity. And finally, shipping address. So of course, all of this wouldn't necessarily capture probably the hundreds and thousands of unique signals that Amazon is capturing on a per event by event basis. But I would say these alone are the main essence of what type of data sources could be useful in order to build this customer lifetime value model.
You'll notice 2 things in terms of the way I approach the clarification. First of all, I define it in a very structured manner. So I define what the business process is, which is very crucial in order to demonstrate product knowledge. And then I talked about the business requirement. When it comes to business case problem, whether it's an interview or in a real life project situation, the first thing that you must do as a data scientist is clearly define what is the scope of the business problem. Now, over the course of 6 years as a data scientist at Booz Allen Hamilton, PayPal, and Google, I've had the opportunity to work on over 12 data science projects. And in every data science project, it always started by defining what the business requirement is. And in the interview settings, interviewers are looking for that. So if you're immediately diving into the technical solution, then that is a found play. So it is absolutely crucial that you clearly define the business objective. Now, another crucial component is that I clearly define what the data sources are. How can you solve a machine learning problem if you don't have any information about the data that you're going to use to solve it? So this is something that you need to clearly define. Now, another core component of how I approach this business case problem is that I actually flesh it out in the Word document. Whether the interview is conducted in Word document, QuarterPad, or some other built-in interactive environment, what you want to do is walk through the process on the document. This is going to help you brainstorm ideas and also reinforce your point so that the interviewer can clearly understand your complex idea in plain English. Now, let me jump to the technical solution part, but before I do, by the way, if you are looking for data science interview prep, make sure you check out datainterview.com. Data Interview is an interview prep platform created by data scientists for data scientists.
For a monthly membership, you get access to courses including statistics, product sense, business cases, and mock interview videos. Also, even a Slack group community. As it's a living course, new content is constantly being updated every month. You can also get coaching and get paired up with a FAANG instructor like myself, an ex-Google, who will give you personalized prep based on upcoming interviews. Clients have used this to land top jobs at places such as Amazon, Google, and Meta. Make sure you check out datainfo.com and ace your upcoming data science interview. Alright, now let's dive into the technical solution. So in order to walk through the technical solution, there are 7 steps that you must walk through. And also the second part of this interview question, which is providing recommendation to the VP, we have to utilize a model we build in order to address that part. So let me walk through the procedure, starting with the EDA and data pre-processing.
Now that I have the parameters around what I need in order to solve this problem, let me talk about the technical solution here. So in order to think about this, I would say that I need to first of all walk through the overall procedure of how I build a model from end-to-end process. The first thing I need to think about is the exploratory data analysis, followed by data pre-processing, followed by feature engineering, followed by feature selection, followed by training the model, followed by model evaluation, and then lastly, productionization. And of course, these steps here address the first question, which is how would you predict the customer lifetime value of Amazon shoppers? And when it comes to providing the recommendation, I'll talk about that after I walk through the procedure of building the model. So the first thing I want to talk about is the exploratory data analysis. And the purpose of the exploratory data analysis is one, to understand the data quality. And this is really about understanding missingness of the signals, along with rare values in the categorical variables and outliers. And the next thing I want to do is do some univariate analysis. And what I mean by univariate analysis is looking at bar charts, looking at histogram. And really the purpose of this is to build some intimacy around the potential signals along with the labels. So that way that's going to help me inform how I'm going to handle outliers. It's going to help me understand the distribution in terms of the mean, the median, the standard deviation. And the other type of analysis I might do is correlation analysis. And what I mean by this is twofold. I might look at some visuals like line charts and scatter plots. I might even look at Pearson statistics. And so one of the purpose of this is to understand potential collinear signals and also to understand what potential raw signal is correlated with the target variable in this case, which is going to be the customer lifetime value. So once I have the EDA done, the next part is to do some data pre-processing. And this is going to come in the form of data cleaning. So we'd consider how I'm going to handle missingness. And that might come in the form of deletion, or it might come in the form of imputation using mean. And for rare values, I might consider the idea of grouping. But it also depends on what kind of categorical variable I'm dealing with. If it's a type of categorical variable that has high cardinality, then I might use some numerical encoding. But if it's a categorical variable with maybe 3 values, then in that case, I might just do dummy encoding. Now, when it comes to outliers, I might also consider perhaps clipping it. Or if the outlier is some sort of reporting error, then I might replace it with a null and then just impute that or consider deleting it. And that probably requires a conversation with the stakeholder to better understand the data quality issue. The other type of data pre-processing that I might potentially do is scaling. And that really depends on the type of model that I'm going to be using later down the road. If I was using a generic linear model that's OLS based L1 or L2, then I would seriously consider the idea of scaling because any data point that has outliers, it's going to influence the model fit. And so scaling might be appropriate here.
So just like how in actual data science project, I provide an interviewer a glimpse of how I would conduct the exploratory data analysis. Now this step isn't something that you need to do a deep dive on. You just need to provide an interviewer a glimpse of exactly what type of EDA you're going to do. And then with the EDA out of the way, I talked about the data pre-processing. And in any standard procedure in data pre-processing, it means that you're performing data transformation, data cleaning, and then you're also getting your labels ready. So all of these elements provide thorough details about how you would do the EDA and data pre-processing. Now, if these are the steps that you have walked through, instead of just immediately diving into what kind of algorithm you're going to use, then you are on the right track. Now let's look at the next series of steps I'm going to walk through. Now, once I've done the data pre-processing, the next procedure is to use my knowledge about the data and extract additional signals that could be useful for the model. So right off the bat, I can think about doing aggregations. And this would be the quickest way to generate as many signals as I can. I have the transaction data. So what I could do is I could look at, let's just say, the past X day purchase dollar or volume. So I'm going to rephrase this as quantity per customer. So this is going to be a set of signals. I can look at the past 7-day purchase dollar per customer. I could also even look at the past, let's just say 14-day purchase quantity per customer. So I'm going to have different windows and I'll pick out the different action to derive as many aggregation signals as I can. And one additional thing I want to mention is that I can also look at various statistical functions. So I can do it at the total level. I can even do it at the average level or even standard deviation. So this choice of the signal in this case is really going to be based on what is the most meaningful information to build this model. And ultimately that is going to be decided in the feature selection stage. The next set of signals I might consider is numerical encoding. So variables like product, for instance, that is going to be high cardinality, meaning that there's going to be probably millions and millions of unique products. And so you don't want to apply dummy encoding. Otherwise, if you were to just have this large dummy variable set and then put that into the model is going to suffer through overfitting, given the curse of dimensionality. In order to avoid that, there's two potential techniques. One is to do some grouping in this case, thereby reducing the number of unique product values. Or you could try to map it into some dense numerical vectors. In this case, what I would try to do is I would actually try to encode it in some sort of like a numerical way. And so that numerical information could be actually derived from aggregations. So what I could do is I could apply a similar strategy where I can look at the past X day total purchase dollar per product. So signals like the past 7-day purchase dollar per product can provide some information about whether this has been a popular product or this isn't a popular product. And that could potentially be useful in the model overall. The other type of information that could be useful is handling the address fields. And I would propose the idea of decomposing it in terms of, let's just say, zip code, the state, and country. And I would say depending on what the state is, the variable, it indicates some information about the person's income status. It conveys some information about their economic status. And generally, I would presume that users who are in states with higher economic opportunity would generally spend much more, thereby would have a higher CLV than users who have low income. So the address decomposition in this case could be useful information. So if I was building the actual model, of course, I would do a lot more exploration in order to really squeeze a sponge of converting this raw variable and try to extract as many signals as I can. But I would say for the sake of this exercise right now, these are sufficient enough. The next thing I want to talk about is a feature selection. So in the feature selection stage, this is where I have hundreds of potential signals, but I don't want to just input all of them into the model. I actually want to only pick out certain ones that are going to matter the most. So there's various strategies I can use. And depending on that, ultimately that's going to affect the outcome. Now, first of all, I can consider the idea of PCA. Forget about what signals I'm going to cherry pick. Let's just compress that into lower dimension. So that way the model is less likely to overfit. However, I believe that this is going to be a little bit problematic later down the road because I have to be able to provide a recommendation on how to increase the CLV to the VP of product. And I need some underlying information about what signal is considered a high predictor for that target variable in this case. So PCA might not be the best strategy in this case. And one other technique I would probably use in this case is going to be L1 regularized regression model for feature selection. So L1, what is it's basically a compression of collinear signals into a coefficient of 0. And that's going to help remove any collinearity. It's also going to help remove signals that are weakly correlated with the target variable. So because L1 can do both, remove the multicollinearity, but also help you keep the ones that have the high predictive power, what I would do is use the L1 regression in this case. Now, after you've done the EDA and data pre-processing, obviously the next thing to do is how you're going to do the feature engineering and feature selection. And that's even before you propose the idea of what kind of algorithm you're going to use. You have to show the interviewer that you can do feature engineering using the raw data because it is important in order to build a robust model. Now, when it comes to feature engineering, you can be as creative as you can. And with the raw signals that I provided, you could probably list about 70 to even 100 of them. But that's not what the interviewers are looking for. They just want to get a glimpse of whether you can do this or not. So in this case, what I walk through are some aggregation set of features along with some numerical encoding and decomposition technique as a way to conduct feature engineering. Now imagine I've combined all of these features and fed it into the model. What's going to be the consequence of that? Well, the model's probably going to overfit because of course dimensionality. So the next thing that you have to propose is the idea of doing feature selection. And when you're doing feature selection, you could obviously use some PCA, or you could use filtering or wrapper method. And whatever you're trying to decide, it must be based on the business case problem you're trying to solve. Although PCA is ideal because it will represent your feature space into a lower dimension, thereby reducing the likelihood that the model is going to overfit. The problem with this approach is that you now lose some interpretability with the model. If you feed into a model that provides variable importance, then you're not going to be able to clearly identify exactly which signal is very important in terms of predictive power. And for this case of problem, what we need to do is we need to use the output of the model as a way to provide a recommendation that could be helpful in lifting customer lifetime value. So PCA isn't going to be something we're going to be using. Instead, what I propose using is using lasso regression, which helps remove multicollinearity from the feature set, thereby allowing me to select the features that I really need. Now let's see what I do next. Now, once I have the feature selected from the feature selection, I'll think about how I'm going to build a model. So first thing to do is choose the model. And in this case, I could consider the idea of using random forests. And of course, there are other type of models I could potentially use, like neural networks or XGBoost. But I'm just going to keep it very simple, and random forest is going to serve as a really good benchmark. The next thing I want to talk about is hyperparameter tuning. So when I'm doing hyperparameter tuning, there's two aspects I need to think about. One is what are the parameters of the random forest I want to try to optimize? And the other aspect is a search strategy. What type of hyperparameter tuning strategy would I use to figure out what the optimal parameters are going to be? And when it comes to the parameters of random forest, and of course there's a lot of these, I would say the three of the most predominant ones are going to be the depth, the number of trees, and the minimum sample split. And the optimal values for these parameters are going to be determined in the cross-validation. And the other aspect that I also want to figure out is the tuning strategy. There are three predominant strategies. There's the grid search, there's the random search, and then there's the hyper-op, or Bayesian hyperparameter tuning. And I would say for this, because random forest is a relatively quick model to train, I think grid search should be sufficient. For other type of models like XGBoost or neural network, it might make more sense to do random search or hyper-op because of the training time and more parameters you might need to potentially search. So grid search in this case should be sufficient. The next part is to think about the model evaluation. So in the model evaluation, I would want to use k-fold cross-validation. And this is going to help me get a generalized error performance of the random forest model. And in terms of the metric that I would use to measure the performance of this model, because it's going to be regression, what I'm going to use is a mean absolute error, or MAE. So I would use this evaluation strategy to figure out how to tune the model.
Alright, if you're with me so far, that is awesome. So this is the part where I walk through the modeling process and I talk about how I'm going to use evaluation. When it comes to proposing what model you're going to use, most of the time you don't need to be so overly complicated about utilizing the state-of-the-art technique. Just proposing simple models such as random forest is sufficient. Now if you propose using a model but then you don't really talk about hyperparameter tuning, then that's going to cost you some points. So you also want to briefly walk through what are the hyperparameters you're going to tune for this model. And then you want to complete the response by saying how you're going to evaluate it. You want to pick out what is an appropriate metric based on whether it's a regression problem or classification. And you want to talk about how you're going to search for the parameters, whether you're going to use random search, grid search, or Bayesian hyperparameter tuning. Now, if these are the 6 steps that you have walked through so far, then that is great. And for most fresh graduates who don't have prior internship experience in building productionization model, these steps should be sufficient in showing how to build a model. And then you could jump right into the second part, which is providing the recommendation to VP. However, for individuals with industry experience, most often the interviewers are looking for whether you have experience in productionization or not. So this is another step that you definitely want to walk through. So watch how I demonstrate this.
All right, so now let me talk about the productionization. So as I mentioned before, this is going to be a real-time system.
Basically, there's going to be a listening event where once a user has been active for 1 month, then there's going to be a trigger point where we're trying to predict what their 12-month sales is going to be. So this real-time system is going to be built using a REST API. And within this REST API, the model is going to be embedded inside it. And what this REST API is going to do is that it's going to receive an array of the future signals, and then this will be input into the model to generate the prediction. And this model is going to generate this output, basically a single value that represents the 12-month sales value for, or the customer lifetime value for a given customer. And other aspect that we also need to consider when we're productionizing the model is the model storage. So we want to store the model, and we also care about storing the inputs and the output results. And the reason why we want to consider that is because once we have the inputs and outputs stored in some sort of database, let's just say Postgres, or it could be some sort of a time series database like Droid, for instance, then we could have it for monitoring. So we can measure the model performance over time. And other type of monitoring we also care about is the latency and bugs. So all of these are useful ways in order to track the health of the model. And one thing I want to talk about is latency as well. So there's something called a model caching, which simply just means that every time the REST API is being called, instead of using the model that's stored and then trying to retrieve that from the storage, which takes some time, simply the model is, the latest model that's already trained is cached in some sort of RAM. So it's much quicker in terms of producing the output. So all of these are the three primary components in order to productionize a model. And of course, there's other things we may want to consider, which is security and stuff like that. But for the sake of this exercise, I would say that this should provide enough information.
All right, so this is the part where I walk through the productionization. I talk about how I'm going to embed it using a REST API. I talk about how I'm going to storage it, and I talk about how I monitor it. Obviously, when it comes to building a productionization, there's a lot more intricate details you can talk about. There are other elements that matter in terms of talking about latency and security, but these are additional elements that you can address if the interviewer asks follow-up questions. But for the most part, the details I mentioned in this segment of the video are sufficient to show that you know how to build a productionization system. Alright, so if you're an industry professional, you've walked through these 7 steps and that is awesome. But we're not done just yet because we have to utilize this model in order to provide some sort of recommendation to the VP that can help Amazon increase the customer lifetime value. So let's see what I propose.
So now let me address the second part of this question, which is providing a recommendation on how to increase the CLV to the VP product. So in order to provide this recommendation, I would actually want to use this model. So this model, since I'm using random forest, contains variable importance. And this variable importance provides information about what signals have the highest predictive power. So essentially the signals that correlate a lot with the target variable, the CLV in this case. So I would probably want to look at the top 5 to 7 signals, because that's going to help me with some exploration. And essentially what I'm trying to do is look at the user segments. So what type of characteristics provide early signals that they're going to spend a lot? Essentially what we want to do is increase the CLV. So we want to isolate characteristics of a user that cause them to spend a lot over the course of the next 12 months. So one way to explore this further is using something called a partial dependence plot. And so suppose that the one signal that matters a lot is their first 4-week spending amount. So the idea is that if the user spends a lot within the first 4 weeks, then that's a signal that they have perhaps adapted to Amazon.com, and so their CLV might generally be higher than users who might have spent less within the first 4 weeks. So we could look at a regression where, let's say like a scatter plot, or it could be like a line plot. Let's look at the first 4 weeks amount on the x-axis and the CLV on the y-axis. And let's see what the trend is. And we can look at additional analysis on this. And we could also look at Prime membership as well. So using that model, let's input a set of signals where the Prime membership is on versus the Prime membership isn't on. And let's compare the output. And if the output estimation for the Prime membership is higher than those who don't have a Prime membership, then I think that
also provides clue that perhaps we need to incentivize users to activate Prime membership, thereby increasing the CLV overall. So we can do a series of this analysis where we can look at the variable importance and the partial dependence plot, and they can help us isolate and better understand the type of users who seem to spend a lot more based on these early signals. So one potential recommendation that could be provided to the VP or product is that maybe we need a better way to get users to activate Prime membership. And that could be some visibility with the UI. So perhaps the way the Prime membership sign up is set up is that maybe it's a little bit obscured on the website. So perhaps for users who are currently using Amazon.com for free, that sign up button could be a lot more visible. Or it can come in the form of maybe an active email campaign. So maybe we can aggressively target users who are currently using Amazon without Prime membership and try to get them to sign up within the first 4 weeks. So this overall provides an explanation of how I would go from the model to doing the analysis and then providing a recommendation to the VP or product.
Alright, so the choice of using random forest was deliberate. Random forest comes with variable importance that can help me pick out what are the most important signals in predicting customer lifetime value, and then I can do a deep dive on that signal by using partial dependence plot. And what partial dependence plot allows me to do is that for a given signal, let's see how the Y, in this case this is going to be customer lifetime value, fluctuates across the X range of that signal. And utilizing that information, I can extract what type of activities within the first 4 weeks are correlated with high customer lifetime value over the course of the 12-month period. So I propose what kind of statistical technique I'm going to use, and then I relate that to the actual business case problem by providing some recommendation. And one of this example being Prime membership. And what I propose is let's look at the activation Prime membership and how that correlates with the customer lifetime value. And if we see that the higher customer lifetime value is a result of Prime membership, then we need to figure out a much better incentive structure to get people to sign up for Prime membership. So this walks through the overall procedure of how I start with the clarification by dissecting what is the problem that is being asked and walking through the steps of solving the problem by demonstrating the 7 steps of building a machine learning model, to utilizing the machine learning model and the statistical analysis to address the recommendation to the VP. Now, if you want to continue cultivating your ability to solve business case problems, then make sure you watch this video, which is another demonstration of me solving a business case problem but predicting flight delays. So make sure you check this out.